Hey everybody, this is Larry. This is the Biweekly Contest 27 on Leetcode. We have 30 seconds to go. Hope everyone's staying good, staying healthy, staying safe, and yeah. Hit the like button, hit the subscribe button. Let me know what you think. Um, so usually I will go over how I solve the problem. The other Larry will talk about it, and then at the end I will go over how to solve each problem and my explanation and details and stuff like that. Feel free to let me know what you think. Which one was your favorite question? Which one was your most hated question? Let me know. All right, let's get started. Yay! And here we go. Q1. Make two arrays equal by reversing subarrays. Um, yeah, so for this one, I'm going to have a proof later on the explanation. But basically what I did was just try to think whether, um, basically here you can prove to yourself a little bit that if you can always using reversing subarrays sort an array. And once you do that, once you realize that, you're like, okay, well, if I could sort the first array and the second array and the target array, and if they equal to each other, then that's good. And that's pretty much all I have. And I did this in 50 seconds and maybe my fastest time, but I wasn't even that fast relatively. So I think I didn't submit here because I just wasn't sure that that was correct. It's a little bit YOLO, I even submit. Um, but yeah, Q2, check if a string contains all binary codes of size k. So this is Q2 of the contest. Here I pretty much knew what I wanted to do exactly because it just seems like a very straightforward sliding window because you're literally giving the window k, a substring of k, and then just keep on sliding that k and then see if you could see every possible number, right? Or every possible binary string. And so here I did a little bit of a bit mask trick where I declare a bit mask where I use, so basically what that code does is give you a one string of size k. Also, it's going to be an explanation, so don't worry, it'll be gone over. But once you do that, basically everything else is just shift left, or sorry, you move your pointers to the right, which means that you minus the bit on the left, and then you add the bit to the right, and then what I did was I put that number that you get in between, you put in a set, and if at the end you have every number or every possible binary string, and there are only two to the k power of them, right? So once you check that as being your set size, then that's pretty much how you would solve this problem. So I knew how to do that immediately, and that's basically what I end up doing here. Pretty quickly, actually. I think I really should have been able to submit pretty much now. But see if you could spot the mistake real quick. I had it off by one, so there's that mistake. I knew that. I was like, oh, yeah, well, I was like, I gave it a quick thought of like, okay, for k is equal to 2, is it 4 or 3? It's 4, right? So that's what I did. And I still get 0. So this part is the little part that I would have been really ready to submit, and it would have been quick. But I print S, S is no good. Why? Why? And then I wasn't sure. I looked at the code. Everything seems okay. And I actually have this blind spot where variable names, I just keep, as long as it's self-consistent, it's okay. I print stuff here. It didn't print, so I didn't even get executed once. Try again. Put it in the main loop. Just a print. Still no printing. So then that's when I realized, oh, I'm probably doing something really stupid. Yeah, and I saw that. I was like, okay, well, I just have to fix this. And that's pretty much Q2. Q3, course schedule 4. So this one was also kind of straightforward. The prerequisite and the course schedule name might lead you to think, and that's what I was thinking initially, to do some kind of topological sort, because, well, that's what a lot of these problems are, right? but the first thing that I did was that you're given a lot of queries, so I just want to make sure that n is good enough, and n is less than 100. And once I was like, this isn't topological sort, this is just query thing, right? And I was thinking, well, that's just all pairs. Like every pair for every vertex, can you get to another vertex given a prerequisite, right? And it only tells you that the prerequisite graph has no cycle, no repeated graph. So what I end up implementing is this algorithm called Warshaw's algorithm. And basically, I create an adjacency matrix. And here right now, I'm actually looking at the inputs because I wasn't sure which direction it's going. And what I mean by that is whether A goes to B or B goes to A as the prerequisite. Actually, probably didn't really matter, but that's what I was spending my time on here. I was looking at examples just to make sure, but I was like, why? Why? It really could have just given one example and it would have made my life happy. But excuse me, some days you're just a little off, and I guess that's what happened here. But basically, the prerequisites list, just the edge list, just allows me to populate the adjacency matrix. And then now I just use Warshaw's algorithm. It's kind of like Floyd Warshaw's algorithm, but it's just Warshaw because this is this is what is called a transitive closure, and as you can imagine, because in this graph it uses something called a transitive property, and that means that if A implies B and B implies C, then A implies C, right? And Warshaw's algorithm is what you use to find the transitive closure of this graph. And then I was like, okay, do I have to do anything funky? No, I guess I just have to put it in an answer array because it's just Boolean anyway. And then I spent some time, which is maybe a little bit sad as well, just just double checking the answers like one by one. And I really wish that they have a checker for you for example cases. But I did one test, I submitted, and it was good, so I was very happy. So at this point, Q4, I'm 6 minutes in-ish. I thought I have a good chance to finish at a very high rank. So this is Q4, cherry pickup 2. So I'm not hustling, but I'm like, okay, I have a mental clock. It's going really well. Let's get it correct. If I get it correct without a wrong answer, I'll probably finish in a good place. So here I read the problem, and I immediately knew that the first thing I had to do was pull up the calculator and pull it out. And I said n is equal to 70 or c is equal to 70. I have first thing I did was 70 to the third power, and I also double checked 70 to the fourth power in a thing that you'll see later. So that's what I'm doing now. I have my calculator just to check the numbers, just to make sure that that is a feasible algorithm. And once I did figure out that it was a feasible algorithm, I start coding on the dynamic programming algorithm. So, and once again, there'll be the more in-depth explanation will be later on in the video because I'm just still talking over my thought process. But the idea is that, well, now I'm doing the base case where if the row is past the last row, then we return 0 because you're not picking any more cherries cherries, right? And A and B are basically where robot 1 and robot 2 is right now. So, and that's what I'm setting up. And right now, I'm also, I think right at this moment, I'm pulling out the calculator to check out 70 to the fourth because the 70 to the third state, that's what I did, do the math on. But then I was like, okay, do I need, inside this algorithm, do I need an order of, like, how much of a graph do we need, right? And it actually turned out it is not n to the fourth, but it's n to the third. But I wasn't quite sure yet how, because I think I don't know. But I added an if statement here, so because there's symmetry, and what I mean by that is that if you could swap where A and B is and it'll be okay. So in that case, it is mirrored. So then you just choose A to be the robot to the left and B to the robot to the right. And I'm doing some like minor optimization. I think before I thought that this may be n to the fourth, but after I wrote it out, I was like, oh, actually, it's just n cubed. because for each n, or for each cell, we're doing 9 units of work, if you want to call it that. It's O of 1, obviously, so O of n to the cube. But basically, here we're just enumerating the number of ways A and B can be. I'm just kind of writing out my mental template right now, so it's not quite, yeah. But after I set up the initial conditions, I was like, okay, what am I doing? I'm just thinking around the conditions. Basically, I have to check that A and B are in bound. I was like, okay, I don't want to copy and paste a lot, so let's just give it variables. And basically, and A, which is why I say the next A, that's why the NA. I mean, it's not a great variable name either case, but that's my thinking. But I was like, okay, if NA is equal to NB, meaning if the robots are in the same place, we only take the worth once. Otherwise, we take the worth twice. Right? Well, not twice, but we take the cherries from A and the cherries from B. And just to go back to the mirrored conversation, here we make A the left one and B the right one just for symmetry reasons. And in theory, this should be ready to go. This is about 11 minutes in, a little bit longer, maybe 12 minutes by the time I actually submit. But I'm just double checking some stuff. I'm looking to see why it is wrong, and I was like, oh yeah, because I didn't finish writing this thing. I think I don't know what I was distracted by. But yeah, it looks good. I submit. This would have been 11 minutes in, 11 and a half maybe. And I got wrong answer. I was like, huh, why? How? What? I was pretty confident about it, to be honest. But I ran code. I wasn't sure. And I was maybe trying to visualize it. So basically, this wrong answer would end up costing me about 8 minutes, which would have been the difference between where I am and about fifth, maybe sixth, because I guess I'm not looking at the Chinese server. Yeah, basically fifth or sixth if I had gotten it right. But the short answer behind my bug is that I started the robots not at 0, 0, and 0 or 0 and minus 1. I started on the one before that. And if you look at the image on example 2, and I'll complain a lot about it later in the video, so I guess you'll see it anyway. But basically, I misunderstood the picture to be you can go left, down, or right from the first choice. So once I fixed that, it was good. But even then, I wasn't sure that that was right just because from the reading. But otherwise, it is what it is. And I mean, overall, still 28th, it seems like, for the contest. So gotta feel good about that. Anyway, hang out with the other Larry. He'll complain about Q4 for a little bit more. But there's also an explanation. So I will see y'all later. That's a stupid mistake, I guess. I mean, I don't even think that's really a mistake, but that's just because. So what happened was that I looked at this one, the example 2, where they drew the robot on top, so that it looked like you could go to the second row, and they don't really have an example to put that, so that's why. Um, hmm. Kind of pissed about that one because that would have put me top 10 maybe. Yeah, it would have been top 10 probably. Now we'll see for 5 minutes because that was kind of an easy contest. But the I mean maybe top 10 because possible that these other people would have like Leetcode is really good, so it's possible that he also misread it the same way. But still, either way, you know what I'm saying, which is kind of sad. Um, because that was just like a really bad farm statement. Sorry, I'm just catching my breath for a second. Let me kind of collect my thoughts before I go over the problems. But overall, like, I mean, anytime you finish everything in, I don't know, I think it was been 11, 12 minutes at the time. Because the other thing was that when I redid it, I still wasn't sure that that was the right answer. And that made it a little tricky because this is not clear that you had to choose the one on the corner, right? I had to kind of make sure, I had to read the statement, but the picture on example 2 was telling the wrong story, I think. So, so yeah, but overall, a generally easy thing, but just a little bit annoyed about it. Okay, okay. Anyway, if you're up to here, we're only about 16 minutes in. Well, let's see. Hopefully, I stay top 25. I don't know. I mean, I have another 2 minutes before these finalize, and it doesn't seem like it includes the Chinese servers in any case. But I don't exactly know my timing right now because I usually do the commentary afterwards. But we'll kind of take a look at that. But just in terms of improvement, but like because I think I spent at least a minute debugging. So even if at 13 minutes I would have been top 5, maybe top 6, something like that. Plus the Chinese servers are top 10. But it's very annoying to kind of get it wrong answer that way. So I'm a little bit frustrated, but uh, but that said, let's go over the problems. Whew. Yeah, okay. I mean, I did okay. Could have done better. 40 seconds. Wow. 45 seconds. I had to double check my reading. That's why 43 seconds. I mean, I did okay, but there are a lot of under minute solutions. I thought I did pretty fast. And second one, I did a stupid mistake. But that's what happens when you don't pay attention and you don't have type safe thingy. But yeah, okay. Q1. Okay. Whew. Q1. Make two arrays equal by reversing subarrays. So the idea behind this problem, for me, solving this problem, the idea behind it, and I wasn't super sure to be honest. And during a contest, you're not always going to have time to prove yourself what it is. And this is a easy problem, so I thought a little bit better in that sense that I was like, okay, it's easy, it can't be that hard. But I wasn't sure, so that's why I hesitated a little bit. And the idea here, and you could kind of guess by looking at my result, is that you can make two array equal or by so basically reversing subarrays is essentially like using two stacks or something like that. And you could the short idea behind that is that you could convert any array to any other array by using reversing subarrays because you can imagine just doing it one at a time, like bubble sort kind of, or insertion sort or something like that, and just get the first digit in the beginning, right? And when you do it that way, the easiest thing is just sort both arrays using that algorithm. And now that you have an algorithm, you're like, okay, and then see if they're equal. And if they're equal, then you're equal. So that's basically my strategy, my idea, my algorithm, and this is one line. I solved in 50 seconds because of that. But yeah, okay. Q2, check if a string contains a binary code of size k. Given a binary string s and k. Oh yeah, so this one was just a rolling window. I actually took a little bit longer on this one because I was stupid. Um, Basically, s is the input string, and I also used s as a variable, not paying attention. And I was just like, why is it not running? And that took me a minute because, Um, but basically, the idea here is that given a string, given any string, and any k, in this case, k is equal to 2, we just look at them one at a time. And the way that I did it is I used bit mask and keep track of the binary number because k is only up to 20, so it could be only a little bit over a million, which will fit in an int is the key point there. But given that you have a string and you're doing rolling windows, basically we just here we're like, okay, this is 0, that's we convert it to binary and then put in a set. Here 0, 1, put in a set. 1, 1, put in a set, so forth all the way. And once you get to the end, if you have all 2 to the k numbers in the set, then that means you're good. So that's basically my algorithm. It's just rolling windows one at a time. And I added this if statement so that we only check to add in if we have enough digits. Otherwise, it's not really, it's only partial digits. And the other thing that I do is that I do current n is equal to mask. And this bit mask, just basically what happens is that, let's say k is equal to 3, right? So this bit mask just gets you ones that are that length. So this is my binary bit mask, and what that does is that it just looks at the last k bits. So here it basically enforces that we only care about the last k bits, and then after we do that, we could add current, and then we keep going until we could check whether it is 2 to the k number of strings or substrings. So yeah, so that, and the only reason why it took so long was because I reused the same variable and it didn't complete. So that was a little sad. But overall, pretty straightforward problem, pretty practice problem, and because this is O of n and this is O of n, everything here is O of so this is O of n, this is O of, and everything else is O of 1. So this is O of n complexity. In terms of space, it will take 2 to the k space max, which is up to a million in this case. And that would be okay because it's only up to a million elements. And the reason why it's only up to 2 to the k is because by pigeonhole principle, basically, even if you have more than 2 to the k numbers, then that means that they will get duplicate anyway. So yeah, cool. So that's Q2. I did spend 3 minutes on it. I probably should not have spent 3 minutes on it. Should not need to. Let's quick refresh. I think this is final now. 26 is a little sad because that was just a silly misreading, and I don't know. I probably could have done a little bit better. Ugh. Yeah, and this doesn't include the Chinese service, so that's, yeah. But I don't know. I mean, that was just like a misreading the problem. I think that's not a great example case, but I'll go over that later. Cool. Q3, course schedule 4. There are a total number of n courses. Oh yeah, so this one, I spent some time. So I spent about 3 minutes, or less than 3 minutes on this problem. So I spent some time on this problem, just trying to figure out what the prerequisite pairs are, because it actually doesn't, and I guess here it tells you here, but I was trying to look for it in the statement, which one is which. Like, given a prerequisite pair, is it the first number that depends on the second number, or the second number that depends on the first number? And it's kind of sneaked in here, but I don't know, I had trouble reading it, to be honest. But the idea here is that you have all these pairs and then prerequisites, and then now later you have to do queries on them, right? To see whether there's a prerequisite. And the idea that I use is called the Floyd-Warshall algorithm. And basically what it does, it also helps for shortest path, but in this case, I guess actually, it's not the Floyd-Warshall algorithm. It is just the Warshall algorithm because this is the Boolean version of it, where basically if it goes, basically it takes advantage of the transitive property, meaning that in this case, for example, in example 3, well, it actually has that already. But basically, if A has a prerequisite of B, and B has a prerequisite of C, then A has a prerequisite of C. So the transitive property generally. And from that, you could use the Warshall's algorithm. Type it up. So you could Google it. It's you could say a Boolean version of the Floyd-Warshall's algorithm that came in a little bit earlier. But yeah, but I did first, when I solved this problem, take a look at the n's. And the n is 100, so I knew that 100 cubed would be fast enough. And even though there'll be a lot of queries, all these queries are all one lookup and adding it to the array, I suppose. So I did not worry about running time at all after seeing the n is equal to 100. And this is n cubed for very obvious reasons, and n of square space also for obvious-ish reasons. But this is Floyd-Warshall, or this is Warshall's algorithm specifically, and it is pretty straightforward. Well, it's a pretty straightforward application of it, but I'll have a link somewhere so that you can kind of learn more about Warshall's algorithm. Okay, Q4. Yeah, I know, I'm annoyed. I'm just annoyed that that's such a silly thing. But I mean, I guess it tells you. I don't know, but this picture though, why? Why would it just not be on the ones? That picture was misleading. Okay. Anyway, enough ranting, Larry. Wake up and let's get this started. So this is cherry pickup 2. So this is a dynamic programming problem, as you may see from the code, which is here. I'll go back to it. Don't worry, I'm not skipping it. But the idea is that a lot of this is going to be dimensional analysis to see whether it's feasible. But the idea is that, well, if you have two robots, you might as well move them at the same time on the rows, right? And if you do that, then you can just how many rows how many rows are there, right? There's 70 rows, I think, because I made sure, because otherwise it wouldn't work. So there's 70 rows. Each one contains, let's call them robot A and robot B, and because that's what I have here. Robot A could be in 70 different places, and a robot B could be in 70 places, right? So from that, we just kind of brute force where it could be next step. And that's pretty much what I did here. So basically, for each row, well, if this is the end of this is at the bottom, we return 0. Otherwise, we go one at a time. We basically go, okay, robot A, go left and right, or go straight down. Robot B, go left, right, straight down. We do the math. This is, remember, left, right, straight down. Not in that order, I suppose. And then now we just check that both the robots are still in bound. And if they're in bound, we just take the min and the max. So this is just basically to sort the two elements so that you can imagine that this is symmetric, right? Like if A is in position 1 and B is in position 5, that's the same state as B in position A and A in position 1, right? But basically, swapping the robots doesn't really matter, is what I'm trying to do here. And in theory, it should save you about half the time or something like that. So I was a little bit worried about running time because 7, this is n to the 4th algorithm, and this is 70 to the 4th, which is probably cutting a little bit close, or at least I wasn't sure, because especially with Leetcode, the timing is always a little bit tricky. And then the case here is that the cost, right? The cost is, well, if they're both in the same space, then you cannot both pick up the space, right? So that's why there's only one cost. And then if they're not in the same space, then you add where they are and add them together. And then the best would just be, the best place for this current state is just going for the next row, with the robots in NA and NB plus the cost. So I thought that was pretty straightforward. I thought I did this pretty quickly as well, but the problem was that, and I was a little misled by this example because I thought that you start before the 0th row so that you could choose on the first row different elements. Which basically on the first row you could select between either the 0, 0 or 0, 1 or 0 and -1 or 0 and -2, I suppose. Basically, I thought that you could have some freedom about it, and that's what I got the wrong answer on. I had to read it, but this diagram was kind of sad face for me, and it cost me 5 minutes and maybe a top 10, maybe a top 20 or whatever it is. Probably end up being top 50, but that's okay. Little bit sad because I feel like they could have also just had one problem and that would have, like one example, that would have solved that ambiguity. I mean, I guess here it does tell you exactly, but that, like I said, the picture kind of told a different story, which is a little bit, and it passed the system testing in the first try, so I guess it gave me a false sense of security and really have to reread these things. But some of that is, of course, that, but people were really fast as well, right? So, and I kind of knew that while I was doing it, so I was definitely, like having that awareness and be like, okay, now you got to do it kind of fast. You can't really do it that slowly. So yeah, okay. So that's all I have for this problem, and that's all I have for this contest, I think, in terms of code review, or sorry, in terms of explaining the problems. Let's see. I'm going to do a mini retro to think about how I can have how I could have done better. I mean, overall, I did solve everything in under 15 minutes. So I can't really complain, but I am going to complain a little bit, as you already heard. So, well, I mean, that was a very frustrating wrong answer, right? And I did make a mistake on Q2, probably like a minute or two. So it is what it is, because that cascades a bit. Because even if I spent like that 1 minute means that I could have been top 25 even, right? So that was an unforced mistake on my part. But yeah, I mean, this one, Q1, I don't think I could have done any faster. I think I just had to think about stuff, right? Q2, like I said, that was just a silly mistake. And I had to print in different places until I recognized that. And that took like at least a minute, which is unfortunate. But overall, simple problem, and I got it straight away. Course schedule 4, yeah, I don't know why they don't just tell you. Like, this is a really weird way as a definition, right? Like, usually they would say something like as a good problem set would have really specific definitions. And what I mean by that, and here is actually doesn't tell you either. And what I mean by that is that it would tell you literally like, A B pair in prerequisite means A has a prerequisite of B. Because I spent some time not showing which direction it was going, and that's why. But overall, once I got that, I pretty much it was right on the first try. The only thing that was a little bit annoying was that even though they do have use example test cases now, I wish they just tell you the expected answer for example test cases. I mean, I know it's asking a little bit more, but all people do is going to scroll up, scroll down anyway, right? So why not just tell you so that, like what are you like catching the two people who misread this once in a while? I don't know. Anyway, that's just a thing. Cherry pickup, like you probably know my complaints about. I think I did this one relatively fast. I was, even though I said I was rushing it, I did try to slow down just so that I want to make sure I get it right. So you probably could have seen me slow down specifically. But that said, I still missed this one case because I thought it started at -1 kind of in a way. But yeah, that's what I have for this contest. I mean, overall, finish everything in 15 minutes. Looks like I'm going to be not in the top 25. I mean, I guess that's pretty obvious. I don't know the Chinese server, so let's actually take a quick look. Just for the ranking. And a little bit of a tip for you. If you want to see Chinese ranking, just add -cn to see the ranking. And yeah, this is definitely not included. So 19 minutes, oof. Oh, Okay, so 1922 only adds 2 people, so I'm like 28th. It seems like maybe not sure, but just by eyeballing. Um, but I still should have like done a little bit better, right? Because I don't know, it is what it is. Anyway, that's all I have for this contest today. Let me know how you did. Which one was your favorite problem? Did you make the silly mistakes that I did? Hopefully not, but let me know if you did. And I will see y'all for the next contest. Bye bye.